This is Melham's Math 222, the beginning part of section 2.2. You have the handout here and an attachment. Some of it may have gotten cut off, but I'll give you the essentials of it. Section 2.2. Y equals absolute value of x is V shape, as I mentioned. So here's the original one. See the V shape. If you put a coefficient of 2 in front, 2 absolute value of x. So in this one, if you plug in 1, you get 1, but if you here, if you plug in 1, you get 2. That makes the function go higher. And likewise, if you plug in negative 1, you also get 2. So this graph right here is going to be 2 absolute value of x. And then negative 2 absolute value of x would just take this steeper V shape and reflect across the x-axis, so it comes down like so. So this greenish one is y equals negative 2 absolute value of x. Number 7, f of x is negative 3 absolute value of x minus 1 plus 1. So here's my regular absolute value of x shape. Okay, if I put a negative 3 in front of it, negative 3 absolute value of x, it makes it go down and it's sharper. So if you see the original V, this one is steeper. So, and it's going down, negative 3 absolute value of x. And then this has the effect of moving 1 right and 1 up. The x minus 1 moves it 1 to the right and 1 up. So the vertex used to be at 0, 0. It's now 1, 1. So I have this shape here, which is the same shape as this, only moved over 1 to the right and 1 up. 13, g of x equals negative absolute value of x plus 2. So you start with your basic square root function, which looks like this that we've talked about. Okay, if I make it into x plus 2, that shifts the whole graph 2 to the left. So this reddish one, instead of 0, 0, this point is now negative 2, 0. So shift 2 to the left. And then a negative reflects across the x-axis. So this red graph shifts down to this greenish one, negative radical x plus 2. Number 15, come up over here, g of x equals radical 2 minus x minus 1. It's better to think of this as the negative of parentheses x minus 2 minus 1. So here's the progression. Here's our standard absolute value of x. If I replace x with x minus 2, that moves the graph 2 to the right. So 0, 0 becomes 2, 0. Notice if I plug in 2, you get 0 here. Then if I put a negative in front of the whole thing, that reflects across the y-axis. So that brings it way over here. So this graph right here is square root of negative parentheses x minus 2, which is the same as 2 minus x, but just to show you that this is the same as this one. And then minus 1 moves the whole graph down 1. So the graph of the original function is this greenish one, where we have to point negative 2, negative 1 here. That's 1 unit down from this reddish one. Okay, and then 19 asks for the graph of absolute value of f. So f of x is 2x minus 3. If I just look at 2x minus 3, the slope is 2, the y-intercept is negative 3, so there's negative 3 over 1 up 2. So there's the original graph. Now for the absolute value of that function, anything that's above the x-axis stays the same, so this part stays the same, but anything below the x-axis gets reflected across the x-axis up to here, which is what I tried to indicate in the notes, so that there is no more graph in quadrants 3 and 4 because you have absolute value. You can't have any negative values for y. So that's what happens in that one. Here's another example of absolute value of a function. So f of x equals negative parentheses x minus 1 squared plus 1. Okay, so you take your original graph and x squared. If you put a negative in front, it makes it open down, and then this moves 1 to the right and 1 up. So negative parentheses x minus 1 squared plus 1 looks like this parabola. And now anything that's above the x-axis stays the same, so this part right here stays the same, but these two parts right here are below the x-axis. They get reflected, so that gets reflected up to there, that gets reflected up to there. 13 and 15 also ask for the domain and range. So for problem 13, if you look at what we got, the domain is from negative 2 to infinity, so the green graph was the actual graph, so we can go from negative 2 to infinity, including negative 2. And the range is from negative infinity to 0. The green graph goes as high as 0 and can go forever down. 15, the domain is negative infinity to negative 2. So negative 15, you can go as far as you want to the left. The furthest to the right you can go is negative 2. And the range is negative 1 to infinity. The lowest y-coordinate is negative 1, and you can go all the way up. And summarizing around here, how does f of negative x compare to f of x? You just get f of negative x is reflected across the y-axis of f of x. So for instance, if here's the original function, you put a mirror right on the y-axis, and the reflection would give you this graph over here. So if this is the original f of x, this is f of negative x. Okay, so that's section 2.2, part number 1.